So the problem of today has to do with elementary group theory, and we're gonna prove that when we have two elements of a group J, X, Y, and they are of finite order n, then Yx is a finite order too. So if G is abelian, it means that multiplication is, we have two cases here. So if G is abelian, then multiplication will be commutative, so we'll have xy equals yx. So if xy is of order n, which means that xy to the power of n equals e, that means that yx to the power of n is equals to e, which this is the natural element of the group. So yx to the power of n equals 3, and we are done. We don't need to do anything because it is abelian. Now we'll come to the general case when it's not abelian, so xy is not equal to yx, general case. But even though we're gonna see that even though xy is not equal to yx, they still have the same order. So we are going to notice that xy to the power of n equals xy multiplied by xy, and here this is n times. Nothing surprising here. This is just the definition. But we're gonna notice that we're gonna try to make yx appear on here. So if we isolate the x on the front and the y by the end, this is equal to x yx, since multiplication is associative, yx and then y in the end. This is n minus 1 times. So this is equal to x yx to the power of n minus 1 y. And using this, we're going to try and prove that yx to the power of n is equal to e. So we're going to write what we know already, which is xy to the power of n equals e. And this is equivalent to what we found earlier, which is x multiplied by yx to the power of n minus 1 y equals e. And now what I'm going to do is I'm going to multiply by y here and y and the natural element by y. So I'm going to have yx by n minus 1 y equals the natural element by another element of the group is the same element, so equals y. So since multiplication is associative, I'm gonna multiply this by this. So this will gonna give us what we're looking for, yx to the power of n, y equals y. And what this means basically that yx to the power of n equals the natural element, because we know that in a group, if we have that an element a in G gives us ay equals y, then a is necessarily the natural element. And why is that? Because the natural element is unique. So the a here is yx to the power of n, and this gives us that yx to the power of n equals e. So yx is of order n. Yx is of order n, and this concludes our proof. I hope this was easy to follow, and thank you. See you soon. Bye.